Today I'm going to continue talking about data structures. This is the third part in a video series. It started out as one video that ended up being an hour and a half long, so I split it into 3 parts. So if you haven't seen the first 2 parts, be sure to look in the description for links and up here for a link to the previous one. And let's get into this subject, which will be a practical application of a data structure you may use when using a database manager. So let's get started. So when I started looking into data structures, I was thinking about database management, something I'm very familiar with, but I thought, well, maybe there's something else I could learn about data structures. But what I found out is when we talk about data structures in computer science, we're talking about how the computer stores data in the disk and how it organizes it in such a way that's efficient for the computer to store it and efficient for it to retrieve it, but has very little to do with how we think about database management. Of course, the database management programs use these data structures, but that's something on the back end. That's the sausage making that only programmers see. Those of us actually manipulating the data don't see how that's done. So let's take a look at some practical application of how data is stored with database management, because that may be what you came here looking for, is how do I store my data? Well, that's more of an abstract. That's more of how we think about data, and the database programs present that to us in a way that we can wrap our minds around it. So let's take a look at how we might do that. We don't need a powerful database management program to handle just, 20, 30, 40, maybe even as much as 50 names or so, and do it in a spreadsheet unless you have some other reason to use a powerful database management program. So think of it like that. You can just columns, rows, data, and there we go. Now, I'm not going to talk about the practical application, like how do we make these tables specifically in MySQL that I work with mostly. I'm not going to talk about the commands that create these. That is a whole different topic, which I'm going to make a whole series of videos on in the future anyway. But I'm going to talk about once you are learning database management and know the commands to actually build these columns and populate these rows with data, here's a way you can structure them to make it efficient for the computer to use. These may be not very efficient for you. Some of these things I'm going to show you will look totally counterintuitive for the way we think of things, but for the computer it's just great, a great way to organize the data. So let's get started with a database like this, but we're going to make it a little more complex, something that can get us into a little bit of trouble. Like, how about a database of family information? So what we're going to do is start with our rows. We'll make this simple. Okay, how about father, mother, and for various social and political reasons, I'm already getting in trouble, but we'll solve that later. And we're going to have an address that's associated with them. And then we're going to have a number of children. How about child number 1, child number 2, and, well, let's see, average family of 2.5 children. Let's make child number 3 because we can't have half children in the database. So there we go. And so we've made that table of family information. Well, like I said, there's actually some political and social problems with this. And even here, child 1, child 2, child 3. What if we find a family with 4 children? That's not too uncommon. So, okay, we'll make another column for child number 4. Okay, then we come up with a family with 5 children. Okay, column for child number 5. And so we have to keep building this up in more and more columns. This is fairly rigid in our structure. Once we build one of these tables, it's going to be the same for every single family. And we see that it's rigid to the point of total inflexibility in doing this. I mean, what if we come across a foster family with 15 children? Yes, I've done that. Do I have to have a column for up to 15 children? Okay, what about the 16th? We don't know how to form this because we never know how the information is going to be manipulated for us. What if one of the children go to college and we need a second address because that's the way we want to have the information for every, now that's going to get into some real trouble. So let's just focus on how we handle the children. So we'll do father, mother, and children. Let's get rid of the address for now. What do we do? Well, instead of having one table with a column for each person, why don't we have a table that has the parents, and then we'll have a separate table for children. Watch how I do this. Now, when we make a table in a database manager, we have some columns for auxiliary information just for managing the database. And for sure, every single table is going to have a column of a numerical index. I'll just make a little letter I here. And so every row is going to have an index number, and usually this will be sequential. It simply identifies that row uniquely to make sure that we are dealing with the row we are thinking of. Because what if we have two people with the same name? And we're trying to put some data into the table and say, put this data in the row for Joe. And there's two Joes. Well, we were working with the data for Joe number 1. Here's row 0, here's row 1, and row 1 is for Joe. And there's row 2, 3, 4, and 5 is Joe 2. Okay. We had pulled out the data for Joe number 1, did some manipulation, added some information, took out some information. Now we have to put it back into the database. And which Joe do we put it back to? Well, when we took that row, we kept track of the fact that that was row number 1. So when we put it back in, we just simply put it back into row number 1, and we don't get confused as to which Joe is Joe. So every table is going to have an index for that purpose, to make sure we don't lose track of what row we are dealing with. But we'll also have other information, and well, before I show the next one, actually I don't need it here. I'm going to make the other table over here, and I will need 2 index columns over here. So there's index column number 1, and there's index column number 2. Let's draw some rows here. And this is going to be the parents. And this will be the children. And in database management, we always link tables and we use names such as the parent table and the child table, or the children table, whichever way you want to say it, because let's say this is a number of vendors for my business. And this would be items that I buy from them. And this would be the vendors would be the parent table, and the items would be the child table. So this is kind of serendipitous that we call this parents and children in this context, but we always call those tables by those names. So why do I have 2 index columns here? Well, of course, we have one index that just identifies each row, just like the other one. And I have another one that links the child back to the parents. Now I'm going to draw here just a simple table. We have parent set number 1, that's going to be Bill and Jane. And parent set number 2 is going to be Joe and Linda. And parent set number 3 will be George and Alice. Okay, and now let's see what children they have. So we start building up the children table, and we find out that Bill and Jane have one child named, let's call that Tom. Let's call the children with a name that identifies them as children, just to help us keep track of this. So there's Tommy, and he is a child of Bill and Jane. So what we do here, we have a parents column, and how do I link this row back to the parents? Well, that set of parents has a nice little index number here. So we'll put another 0 over here. So the 0 just identifies that row in this table, but the second 0 identifies Tommy as going with row 0 over here with Bill and Jane. And let's say they have another child named Sue. And so we put a 0 there that links Sue back to them. So when I search this database, let's say I want to find, well, I'm going to tell the program to go grab me the family of Bill and Jane. I'm going to write a program that goes out and grabs that row, and then the program's going to go to find the children. It's going to pull in the children's table, and it's going to go and find each child whose parent column links back to 0. So it's going to go grab Bill and Jane, and then it's going to go through and say, okay, this row belongs to them, that row belongs to them, so here is what it's going to present to us. Bill and Jane and Tommy, and we'll call that Susie. Once again, identify the children with children-like names to make sure we don't lose track of what we're doing here. And so the database manager was able to put that family together from the 2 separate tables. And let's say we go to Joe and Linda, and they have a child, and we'll call that one Billy. And so what's going to go in the parent column to link Billy back to Joe and Linda? That's going to be a 1. And let's say that's their only child, so let's go on down to George and Alice, and they have a child that's named, let's say, Bobby. And how do we link that back to George and Alice? With the number 2. So we go to update this database, we get some information, and we find out that Joe and Linda had another kid. So how do we put that in there? Do we have to do any rearrangement? No, not really. Joe and Linda had another child. That child's name is, let's say, Terry. Is it a boy or a girl? Terry. That goes back to Joe and Linda, so we put a 1 there. So now, if we go to get Joe and Linda's family, the program will grab that row, and then we'll search the child table. So we've got Joe and Linda, and it'll go down here. Okay, they're row number 1. So let's look for children with a 1 in the parents column. We got Billy. And we have Terry. So it was able to grab that information and present it back to us. And of course, we have to change the information. It will just simply put it back in the way it came out. If we say, well, something happened to information about Terry, and we put that back in, we put that back in this table, and if we need to, put information back here. But you can see that when it comes to pulling the data out, it's able to link those tables together. Now, if you're looking at data structures in computer science, you might look at this and say, oh, that's a type of a tree. But what type is it? Is it a binary tree? Is it, it's kind of is a tree, but it's kind of its own kind of tree because we can have any number of links linked back from the children table over to the parent table. Now, this is a very simple way to link information between 2 tables. This could be, like I said, could be vendors and products, or it could be customers and invoices. Who knows what you could do, but it's a very simple way to link those back and forth. And if you think about it, you can see all kinds of ways you can use this particular type of structure. But for families, actually, this can be more problematic than useful. At first, it looks like a very good way to do it, but families can get so complicated that this can actually run us into trouble. People get divorced, children grow up and get married, people adopt children. You end up with families where one parent has one set of children, the other parent has another set of children, some are both. And then again, even just the political and social implication here of who's the head of the family. Some people are going to be problematic with this, and I don't have a problem with that because it's an easy solution. But let's see how I would really solve this problem of just doing a set of families, which might be a very common thing you need to keep track of in a database.